We already had answers for majority of the questions. Maybe we just at that point we hadn't. I would say we weren't sure of how to clearly communicate that at that point, but now we do. And so in the subsequent review, which was about 2 weeks ago, maybe 3, um, let's see. There was. Let me show you what was said. All right. Okay, so this is from 15 days ago, or 2 weeks. I have a bunch of concerns still noted below. Much less than before. Some are big. Access control, cardinality, etc. So access control is what I was saying earlier. Who gets to use which bucket class? Who gets to use? Who gets to bind to a particular bucket if it is unbound? That's what he means by access control here. Cardinality is getting rid of. So Tim has been proposing that we get rid of bucket access request. Just use the bucket claim or the newly termed bucket claim, which would be the equivalent of bucket request. Um, uh, those are the big things that he sees, but mostly it's okay to proceed. I think there's a ton of work to do between alpha and beta. And
Is
then
it
he
Sid?
wants to do.
Can you clarify? Is he wanting to collapse now the bucket request and the bucket access
Yeah.
too, or just so like when would credentials get minted?
Yeah, I don't think it makes sense either. I think we should make that clear. Uh,
Yeah, I mean,
so
that's been our stand from the beginning. Is there's a creating a bucket and creating a credential for a bucket are two distinct operations, and we want them both to be explicit and not have any
right.
implicit things going on.
Yeah, because the life cycle of credentials and life cycle of buckets are entirely independent of each other. So yeah, we do need two separate resources for that. Um, okay, so let's review them one by one. Okay, um, so on name, so this is what he's these are the open. This is one of the main ones. So let's say bucket claim is a thing that holds the bucket alive, or whatever claim holds the thing alive. So he thinks we should rename bucket request to bucket claim, and bucket claim right now, which is called bucket access request, to bucket access. But I still hope you can merge bucket
Okay, so
claim.
we'd still have two things. They just be called bucket claim and bucket access.
Right, as I read it, yeah, that's what he's saying. But I hope you can merge bucket claim and bucket request to one thing.
But
But if not,
the
what does he
answer
think?
is no, and it would be good if you understood that and why.
Yeah,
Right.
yeah. So in the current definition of the KEP, in the current version of the KEP that's in this PR, before having addressed these comments, what we've said is bucket claim is bucket access request is renamed to bucket claim. So when he says bucket claim here, he means bucket access request. Um, so he's talking about merging bucket claim and bucket request to one thing. Or am I reading this wrong? What does everyone else think?
Sorry, I'm on a phone and it's very, very small. Let me zoom in.
Okay, so he's just saying he wants to merge bucket access request and bucket request to one thing. Obviously, that's not possible. We can respond saying that that's the case.
That's been our stance up until now. So like, I think that there needs to be an argument about, is there a good reason to do that or not?
I mean,
We don't think so, but if he has a really strong reason, we should hear it.
yeah, we have a strong reason to have them be separate. Um, which is really what I was saying earlier. The life cycle of credentials and the life cycle of buckets are independent of one another. So, I mean, a resource is expected to represent the life cycle of an object and help manage it. In this case, we couldn't possibly combine them too. The only case that can be made for being able to combine them is if that single resource which represented both the creation of a bucket and usage of a bucket had a many-to-one relationship with the bucket. So for each request for a bucket or each bucket claim, um, or multiple bucket claims could point to the same bucket. And if the bucket didn't exist already when the claim was made, it creates it. If it already exists, then it just points to it, I guess. Something like that could be done. And then the bucket claim could always be used for holding access credentials for that bucket.
Well, we could make credential minting implicit, right? Where it just happens just in time when a pod tries to bind to a bucket and there's no Kubernetes object that represents it. It's just some state floating around inside the cozy driver. Well,
how would you do credential rotation, or how would you do different types
yeah, I
of
was gonna say
access?
that it seems like I'm trying to think through Tim's logic. If Tim understood how this level of it worked, and he was still trying to make the argument for we need to only have one object, then the only way to do that would be to say, yeah, credential minting doesn't have a specific object in cozy, and it's somehow implicit in the state is stored elsewhere. But yeah, that creates a bunch of new problems that I think is why we prefer the existing solution. So we just have to push back and say no. The access is separate, and here's why.
Yep. Yeah, I think that's fair, and I think that should go well. All right. So the next thing is access control. So he's explained it here. Um, so Google Cloud currently prefers workload identity-based authentication, as in not access keys and secret keys, but some way to say that a request coming from a particular pod is indeed coming from that pod, and so they should have so and so permissions. So he's
Same,
talking about.
Same in some AWS-based deployments, if I'm not mistaken.
Right. Our stance on this has been that we'll look into it when we go into post alpha. But I guess what he's saying is we should at least have a plan of what it would look like. Excuse me. I think that's what he's asking.
I think what he may be hinting at is that we should split on one hand the creation of authentication tokens, which like on Google Cloud and AWS would be a no-op because the token already exists and is already exposed within the workload. And the granting privileges to access the bucket to that token with a little bit of hand waving here, which would still be required also on Google and AWS and others that have this integrated authentication.
So you're saying that I think we're saying the same thing. So let me reiterate what you said and let me know if I got it right. So you're saying that Tim wants us to have two different styles of authentication. One, access key, secret key based, and the other workload identity based. Is that right?
Yes.
Yeah, that makes sense. So yeah. Okay, so that's what is. We've talked about this. We said we'll do it after alpha, but maybe now it's time to actually go over how it's going to look. There are some unanswered questions in that space. So with access keys and secret keys, it's pretty clear how we want to orchestrate the whole thing. When a bucket claim is created, well, our current, let's call it bucket access. Let's start using the new terms. Bucket claim will be the equivalent of a bucket request, and bucket access will be the equivalent of bucket access request. So is that clear? I'm just going to take silence as a yes. Okay, so currently when a bucket access is created, we end up creating credentials and holding them in a secret, holding the actual access key and secret key in a secret object, and then plugging the secret into the pod. The other authentication mechanism is somehow saying that a particular pod is has a particular identity. So the way that generally happens is either through a metadata service, like on AWS. I don't know about other clouds, but on AWS at least, there's a metadata service, um, which is like a reflection API. So when you query the same link, so there's something called as a link local IP. I'm sure many of you are aware of this, but it's a static IP address, and depending on where you ping that IP from, you get information about you get information about who you are. So for instance, if I'm on instance 1, let's say in Amazon, and I ping my link local IP uh, and and look for instance name, I'll get the instance name of instance 1. If I'm on instance 2 and ping the same API, I'd get the instance name of instance 2. So that's the metadata API. So in order to talk to S3, what happens is uh, in Amazon, in order to talk to S3 with the workload identity based authentication, it pings the metadata API to get back a token, an STS token, simple token service. That's what STS stands for, and then uses that token to request access for that, or to read and write objects from a particular bucket. It's just I'm not sure if that's the way to go about in case of Cozy 2, but we need some kind of token that identifies a particular service to be a particular identity. Does that make sense?
I think that the problem is what's going to work in every environment, right?
Mm-hmm.
Kubernetes has many different ways of deploying, all the way down to like kubeatom on a VM.
Mm-hmm.
Like what you got kubeatom on a VM, what tokens do you have that are meaningful other than the ones Kubernetes creates itself?
I mean, where we can't support it, we say we don't support it. We just
Okay, yeah.
Mm-hmm.
So that would be the key is to know when you can and can't use that
Mm-hmm.
that facility,
Yeah.
and to have a reasonable fallback when you can't.
Mm-hmm. All right. How would that API look? How would we go about this? Let's start with the simple question of how would they specify that they want a particular kind of authentication from the user's perspective, someone asking for a bucket, access to a bucket. So
It might
Mhm.
be better left to the admin than the user.
So a bucket access class.
That would be my default,
Mm-hmm.
is to say, the admin who sets up the cluster knows where it is and what its characteristics are, and can configure good security practices, and then the workload then can be portable, and it doesn't care whether it's running on kubeatom or running in Google Cloud or AWS or wherever. It just it's going to use the default BAC, and it's going to get whatever security parameters that specifies. And I haven't thought through what that means, but like that seems like a good starting point, to say that this is not a user concern, this is an admin concern.
I agree.
The problem is I think if we think it all the way through, it may affect the structure of the workload itself. Like the workload might get a different experience depending on what environment it's in, and then you lose your portability. So I don't know enough about STS to know if workloads can be portable to either environment.
Yeah, that's a good question. Let's look up how identity. Yeah, workload identity AWS says GCP workload identity. Interesting. Yeah. Instance IAM AWS. So, and let me also put in metadata service here. I'm just quickly looking up how it does it. Yeah, I'll have to read more, but if someone knows about this, please feel free to speak up. Even if it's about a different cloud, it's just that I have more experience with Amazon Cloud and on-prem than I would say the others. All right, so yeah, let me do some reading on this and figure out how exactly it does it, so that we can see if it can be applied in some way to a different provider as well. So Ben, to address your question, I just thought of this. So it doesn't really affect portability, right? Because let's say again, it's an admin control resource. So um, all standard clients for S3, at least S3, I know that support multiple forms of authentication. So one of them is access key, secret key, and then there's a whole bunch of others. So AWS SDK.
Well, so this is going to be the key. If we're going to say that you have to use one of these SDKs that supports both, and rely on the fact that the SDK can transparently deal with both,
Yep.
then we're done. But like that's a very specific requirement to put on applications.
Well, this is the standard SDK for AWS. AWS SDK go-to from the AWS.
But not everyone uses that kind of stuff, right?
I know
There are
Minio
other.
does. I know Minio gives the same thing, because there is a hierarchy. There is like an order of precedence when it comes to using credentials from the environment. And the last one goes to access key, secret key. There's process credentials, endpoint credentials, role. I think this is the one that is the see get metadata API. So it calls Mhm.
My concern is that like this creates a dependency, right? It means we effectively depend on this thing, and there's versioning concerns. If they introduce something new that changes the behavior, that breaks us, we have to worry about that. If there's very, very old versions that can't support some of these features, that we can't support those, like it just becomes a compatibility thing where we have to say, like, we know these versions work and these other versions may or may not work. And
Yeah, we'll need to offload that to the driver somehow.
no, this is Cozy's downward API to the workload. Like we have a contract between us and the driver, and we have a contract between us and the workload. And this is a concern for workloads only, right? The drivers just have to do what they do.
If we try to represent, or if we try to, if Cozy tries to represent things like metadata API version and IAM instance version, I don't know, whatever that is, we'll end up in a hellscape where it'll be hard to manage.
No, yeah, but I'm talking about we have to have a compatibility matrix for S3 client versions. At the end of the day, that's where this will put us if we say that we're just going to depend on the fact that the AWS SDK can deal with all of the credentials that we may supply, then that means that we're beholden to that SDK. And if it changes, we just have to publish that it doesn't work.
Yeah, I think okay. So this is the primary one. This is the main SDK. Let's look at Minio SDK.
Just a quick question: is it possible to leave that up to the user and create a secret that Cozy can just pass to the driver or whatever the next layer is and say, the user has created these credentials because they know that of the driver necessities, and it just kind of opaquely gives the secret contents to this next layer and then just calls it a day.
But that destroys portability. Like we need to have a situation where no matter what environment you're running in, and no matter which Cozy driver is installed behind the scenes, the workloads need to be portable across implementations.
That's going to be. Yeah, I hear you. I completely understand. I'm just thinking that may be tough. It's like putting a
it is tough. And it's why we started with like secret access key, secret key is all we support, because like that's the lowest common denominator that we know we can guarantee 100%. The problem is that it stinks, and these other mechanisms are better. But then the question is, how do you guarantee those across the board? Because you don't want to have a situation where some workloads run on some clouds and not other clouds, because then Cozy is kind of useless, right? If it doesn't provide portability.
Yeah, I hear you, and I hear where you guys are going, but I'm just looking at it from the PVC, for example, PV point of view, and the storage class point of view, where that level of request is not done at that level. It's actually pushed to the admin to say, if you figure it out, and then we'll take this parameters and give it to the driver. You see what I mean? So in the PVC model, there's no, we don't bring all these things up to the user.
Well, I don't agree. I think that the contract with PVCs is you specify volume mount in your pod definition, and you're going to get something mounted at that path. Now, it could be an NFS share, it could be an XFS file system, it could be an ext4. I mean, there's some things that you're going to have to deal with slight differences, but the basic guarantee is you're going to get a file system mounted at the place you asked for.
Yeah.
It's going to be writable, presumably. Yeah. And so we need to be, Cozy needs to be able to make a similar guarantee. Like if you say bind my pod to this bucket, then there's going to be something that you can expect 100% of the time, and then there'll be other things that may vary, but we want the thing that you get 100% of the time to be, the case that everyone relies on, enough to basically write a portable workload.
So I completely agree. Just a quick thing. Is that I completely agree with you, Ben, what you're saying. It's just that in that part, when the PVC gets that explanation in the mounted port, you still need the storage class, and the storage class is what provides that abstraction. Sorry for my dog.
Yeah.
But
yeah, go ahead, please.
I was just going to say that I'm just trying to avoid creating a possible, all-encompassing object store API that abstracts everything, because it's going to be a tough answer. So instead, I'm trying to say the way the storage class does it is that it says the admin understands how the storage system works. They put everything in there that it needs to be done, and they can even point to a secret that can be done for that storage class for that storage system. But the user then just points to the storage class and says, I just want to use that, and they consume it. You see what I mean?
We have something similar. So the issue here is between, the difference between PVC, PV, and buckets is that the wire protocol, the read-write protocol is not standard. So with PVCs and PVs, the protocol to access data is POSIX. You read write all through syscalls, and it's stable regardless of what provider it is. It doesn't matter who the backend storage is. But in case of buckets, it's different. The clients, if they have an S3 client, the S3 client needs to support the kind of authentication that we're asking for. Similarly, if it's a GCS client, it can't use S3 style authentication.
Exactly. That you're hitting exactly what I'm trying to say. It's like the client is already opinionated, is what you're saying, right?
Yeah. Well, but we had hoped to limit it to like it's either S3 or GCS or Azure Blob, one of those three. But like within S3, like it should be, everything should be the same. That was the hope. We don't want to go down to the next level and say, well, within S3, there's multiple sub variations, because then your portability starts to go out the window, right?
Yeah. And I think I'm going back to it, and I just think that the client knows with that version of the client, with that version of the server, it's going to be really tough, right? I'm just saying, let's pass that to them. because they need to pick it. They're gonna have to be opinionated anyway. They can't take the S3 client connected, for example, to Azure's blob, right? So they already have an opinion of exactly what they want.
Okay, so yeah, so I just looked up for the 3 major clients that are being used. Boto 3 is I would say the one that I'm sharing on the screen right now. This I would say is the second most used AWS SDK for S3. The first one is obviously the official AWS SDK. The third one I would say is Minio. So all 3 of them support instant metadata style access, authentication. So I think it might be okay to assume that all S3 clients support instant metadata style authentication.
Once we start assuming things and without like a survey, it's gonna be really hard. We're gonna find edge cases, and that's what I'm
yeah,
trying to say.
No, for
my-
sure.
my-
That's 100% for sure. If anyone's writing their own S3 client, that's a possibility. But we can address that with documentation and just better, just docs and maybe with the API we can communicate it a little bit.
If we can be precise about exactly what the downward API will include,
Mhm.
and then we can ensure that that is a subset of what a standard S3 client can consume, then it does become, the workload's responsibility to just say, well, if I'm not using a standard client, then I can go read this doc to see what I have to deal with.
I think that's possible. I think it's possible to differentiate between different authentication styles. What if under the protocol structure in bucket class, bucket access class, let's see, we specify a credential chain. So that's what we call it in Minio. We call it a credential chain. That is, you can say, pick up from AWS environment variables first. If not, pick up from Minio environment variables. If not, do third style and fourth style and so on. What if we were to do something similar with our bucket access classes?
But we absolutely can. But my worry there would be that if like you try to set some precedence that doesn't match the precedence of the underlying library, like if the underlying library wants to prefer an STS token to a access key secret, and you return prefer access key secret to STS token, you might not be able to even make it behave right if the SDK is unable to follow your precedence rules because it has its own. But in principle, yes, I like the idea of saying we're going to get, we're either going to give you A or we're going to give you B, and to be compliant, you have to be able to consume both.
It's just, yeah, I see the
because
problem.
then as a client, if I'm writing my own S3 client, I may get an access key secret and I may get an STS token, and I have to, and I can't count on one or the other, so I have to implement an if-then kind of a authentication scheme. and that's
okay, so
fine.
yeah, that wouldn't work because we can't say we support one or the other. We should say
we should say that
we support
what
all.
you will get one or the other depending on what the admin has specified in the bucket class or the bucket access class. And as long as you code your client to support both, you're going to get one of the two.
What if we said
maybe three? Like I don't know,
yeah, you can
enumerate
have
them
n, you can have 10 even. Like, so what if we said it like this? What if in the bucket access class you specify what all are supported by the driver, and in the bucket access object that the developer controls, they specify which exact authentication mechanism they need.
That sounds good. Then you can leave it up to the user then to pass that down verbatim.
And,
right, but then they're not portable. If you move to another cloud that doesn't have that,
yeah,
it's not portable anyway because the library is not portable. It's already opinionated.
No, S3 is a de facto standard with dozens of implementations. Like if I code my workload to be S3 compatible, I should be able to run it practically anywhere.
Yeah, without changing the definition.
No, I hear you. So if you S3 compatible, then I just let me reword it another way. I'm trying to make sure that Cozy is not an S3 abstraction API, right?
It's not. It's not a data abstraction API. So where the problem we're seeing. So Ben, S3 is standardized, but the authentication mechanism to talk to S3 is not.
Well, the access key secret is, but the other ones aren't.
Yes.
Yeah.
That's right. So
but let me just ask it this way. So Ben, do you think what Sidhartha just said would not apply? Because if the driver said, I support the following authentication models, and then if you have them, do you, and that's just a secret for you, it's not, it's still the same library, would that be okay or no?
No, I think we have to have a contract between us and the drivers, and we have to have a contract between us and the workloads. And I'm very much concerned, and the contract between us and the workloads has to be much more strict, because that's where we get portability from, right? For Cozy to have value, people have to believe that if they code their workload to it, they can write once, run anywhere. And to make that true in practice, you need to have a very strict set of things that you can have that might come down from Kubernetes to your pod, so that you can support all of them, and then know that no matter what Kubernetes cluster you end up on, if it has Cozy, it's going to work.
So let me.
I guess Ben.
Mm-hmm.
Sorry, I had a question. Like, I'm not sure how different is this compared to, like, we have drivers, like for PVCs, PVs, we have a lot of features, right, that are optional, and not all drivers support everything. So we have like capabilities to do that, and that potentially results in non-portability because certain drivers only support certain features.
Is it okay to say,
right?
Yeah?
But the set of things that are non-optional is big enough that you can write your whole workload that way and not use any of the optional stuff, and you're fine. Like, you don't need to resize, you don't need to snapshot, you don't need maybe some other funky stuff, but all the basics work 100% of the cases with PVCs. If you code your workload to depend on a PVC, you can be sure that it's going to work anywhere.
I mean, is it fair to say that for there is change required in application code? Like, we're going to take that effort to go and update the APIs, to go and read Cozy credentials, the SDKs. I mean, so I mean, we could get to that point where we target the most important or the prominent SDKs for each of the clouds, just the main ones supported by the clouds themselves, and add a credential provider for Cozy, specifically in the context of S3. What if we did something like that? That way
I'm just saying we have to have a very tight contract about what Cozy will provide to pods when they try to attach to a bucket. Like, they can't be, you might get any one of these 10 things, you might get something proprietary that you don't know what the hell it is, because no one can write a workload to deal with proprietary, credentials from whatever cloud it happens to be running on. It's just not practical. If you want to write a portable workload, there needs to be a strict set of possible inputs that's as short as possible.
Yeah, I think that, this is just my opinion, but I feel that, and Sidhartha, I think you mentioned that, is like, we already have a client that has made a decision to use a certain API to access a certain object store. So that already creates a model where it's no longer the same as PVCs, because it's no longer able to just immediately connect to any object store. So I don't know if we want, what I'm trying to say is that I understand the goal you have, Ben, but I don't know if it's even possible.
No. So Luis, yeah, that's a very good point. The thing is, we're trying to standardize for a protocol. Our boundaries lie inside of a protocol. So we call it protocol, so a data API. So if it is S3, we're trying to say that all S3 clients, you can move between S3 providers like Minio versus Ceph versus Amazon itself. And we want to maintain that level of portability. we can reason about why we can reduce the scope of portability. We can say it's not just S3 protocol, it's S3 and a particular authentication mechanism. But if there is an authentication mechanism that is AWS only, let's say, or Minio only, and they do exist, just to be clear, if that's the case, then we lose that portability, the little bit of portability that we were able to offer initially. So it's just the scope of portability keeps reducing and probably
So-
lost at this point.
Let me reprise an argument that I made a long time ago that some of that Luis might have not heard. Like the battle we're trying to fight here is that you can already use object storage in Kubernetes clouds today fairly trivially, right? Anyone can write a pod with an S3 client, inject their credentials through whatever mechanism they want, provision the bucket through some other mechanism, and off you go, right? Using object storage in Kubernetes is not hard today. The point of Cozy is to make it even easier and portable. And if we implement Cozy in a way that doesn't give us the portability, we haven't achieved anything, right? Because you can already use object storage in a proprietary way in your pods. So Cozy has to give you something on top of that, and portability is the thing that we want to offer.
Yeah, portability
by making
is
it a standard
important.
Kubernetes API that you can just code your workloads to use object storage and know that it's going to work everywhere. That's a step forward.
Mm-hmm. Yeah, portability is one of the most important goals here. But again, the scope of portability can be slightly redefined, Ben. Just a thought experiment here. I don't think we should go down this path. I'm saying this with this disclaimer. What if we said it's portable for a particular protocol and authentication mechanism instead of just protocol? Just like we saw, the top three SDKs support the same forms of authentication.
So you're saying bifurcate S3 into like S3 with access key secret, and S3 with STS token, and maybe S3 with option number 3, like, and you have to pick one of those when you provision your bucket.
Or the other way, where when provisioning a bucket, you say, so in the bucket access object that you specify, you say these are all the types I can understand, and the backend gives you one of them if it supports it.
Right, but what if the set that you request and the set the backend supports doesn't overlap?
Then we reject it. So we say it's not supported.
And now you're not portable anymore.
No, but the backend doesn't support it anyway.
Yeah.
But we can do that, but we can also mandate the lowest common denominator and say, look, everyone has to support this one.
Fair
and
enough.
then if you don't do that, you're not Cozy, right?
Yeah, you're not Cozy
if we mandate a minimum that everyone has to support, that buys us portability, even if it's less secure. Like,
right.
I hear you. I do. But if we do that model, the only winner is going to be Amazon, because they're not going to move. So then you got a lot of storage systems and Minio that must apply to that.
No,
but everyone supports access keys and secrets.
Right.
No, what I'm trying to say is that I understand what you're saying, the Cozy driver, then you're not Cozy compliant. But what I'm trying to say is that if this releases that way and we start using it, what we are saying is that you must, the company that doesn't move is the one and that everybody wants to use. That's going to be the standard, and then everybody else going to have to change to say, well, I thought I was Cozy compliant, but I now have to change because that other company who's bigger than me is making it that I have to change my driver because.
I see.
You see?
So you're saying applications you're saying applications can always fall back to access key and secret key. They'll never move on to the more secure, better forms of authentication because this is always going to be supported. That's what you're saying, right?
No. What I'm trying to say is that this is more of a it's not a technical thing. What I'm trying to say, it is more of a community thing where a Cozy driver that's owned by maybe a small company that's trying to do the right thing, and then a Cozy driver that is done by a large company that just says we're not going to change our specs to satisfy and whatever Cozy says. So now the spec changes to satisfy the large company. You see what I mean? That I'm trying to
think
make
that
it.
risk. I think that risk is non-existent here, mostly
Okay.
because all of them support access key and secret key.
Are you aware of anyone that does not support those? I actually don't even know anyone does not support it. If they say S3 compatible, then they will support that, I believe. Anyone does not, then why
Yeah.
they are called S3 compatible?
Mm-hmm.
Yeah, I mean, S3 isn't much more than the access key, secret key, and a little bit of
Signature.
HTTP header mumbo jumbo. That's
Right.
really what S3 is.
Yep, that's all it is.
I think my main concern though is going to be adoption, right? If
Yeah.
we stick to lowest common denominator and we don't offer like the ability to use all of the advanced features that like systems can offer, I
We're
feel
limiting
like
it.
that's going to hinder adoption.
Absolutely. Absolutely. So in that spirit is why we're talking about. So for
Well,
vendors that
I think
support-
that's where the capabilities come in.
right.
So Michelle, the struggle we've had is we know there's a bunch of cool optional capabilities that we want to expose, but like we're trying to get to alpha, and like if we load up the kitchen sink on our way to alpha, like we might never get there. Like the plan was to get a minimum viable alpha that really is portable, and then to come back and start layering in a bunch of optional better ways of doing things. But understanding that like you need a three-way agreement where the workload has to agree to it, the Kubernetes release has to, or the Kubernetes controllers, the version of the Kubernetes controllers you have has to support the capability, and the driver has to support the capability. And if all three want this new optional feature, then you can enable it. But
How does
we were
CSI do
trying
it?
to stay away from a bunch of that in the version 0.1. Just
How does
because it'll,
CSI do it? CSI has optional capabilities, like, right? How does it do it?
yeah, but the first release didn't have any optional capabilities. That was the whole thing, right? The first
I think
release,
for
everything's
CSI,
mandatory.
only the mount, right? The
No.
node publish volume, that's the only thing that is required. Everything else is, even create volume, that is optional.
Yes, correct.
ReadWriteMany. Let's talk about ReadWriteMany. So that is driver specific, and
But that's not supported by everyone either. That's just
right.
one.
How do we
One.
how do we keep it portable?
That
Yeah,
was
you
because
cannot
it was in the
port from
PVC
one
already.
domain.
It was in the PVC already. Read write many once, read
Yeah,
write many, and then the driver, then the controller actually changed that to the Kubernetes speak to the CSI speak, and then so it was able to get back if saying the driver does not support that, then the request is annulled.
What, can we do something like that?
But there is a bit of a, I'm not sure we can make that analogy because in CSI, those optional things are not observable by the application that actually runs.
Well, with ReadWriteMany, you could make the case, right? Because with ReadWriteMany, maybe you'll have to implement a file lock now to make sure two different pods don't write on on top of each other into the same file. Like there
Correct.
is a little bit of that. I wouldn't say.
well, no, I
it's
mean, if you ask for ReadWriteMany and the driver supports it, you will get it, and then multiple pods on multiple nodes can use the same volume.
right.
If the
But
driver
what
doesn't
about
support it,
portability there? What about portability there?
your PVC just won't bind if it's not supported, and that was
Yeah,
Isn't that similar to what we're talking about with the protocol
Yes.
credential, right?
the difference is that like all the PVC API pre-existed CSI, and so we were building CSI against an already existing workload facing interface that we couldn't change, right? We might have done things differently if we had an opportunity to change the PVC API when CSI was invented, but we
So
couldn't.
my understanding is that the PVC itself has to be portable because that's user created that one. But the storage class that can be different, right? Because that's vendor specific. And then I think PV also, that's an admin thing, so that can change. But supposedly you can just move your PVC from one environment to another. But that's my understanding. I mean, this is
Yes,
a high level.
That's the goal, is that your PVC and your pod can go anywhere, and the underlying details are the admin's problem to sort out.
Can we do that the same thing here? So in the bucket claim object, we specify this is the exact access mechanism that I want, and in the list of capabilities in the driver, it specifies that these are all supported. And only if it's supported, we go ahead and provide the bucket.
But your bucket claim that's for an existing bucket, right? The bucket request is for new bucket, isn't it?
Right.
Right, but that's all
access.
that's all driver side concerns. On the workload side, we have to have a stance of like we're either gonna I'll always give you an access key secret, or we're gonna say we may give you an access key secret, or we may give you an STS token.
No, why not? Why
but
not
like-
just let them specify? They say precisely, this is the kind of credential mechanism I want. And if we don't support it, we say no.
Yeah, it's almost, yeah. I think what you're saying is it's PVC already does that with read write and rewrite many.
Mhm.
If we go down that path, we're going to have to enumerate all of them in our Cozy API. We're going to have a list of every single supported authentication mechanism, and there won't be any like magical opaque authentication mechanism. Like we can't allow that. It would have to be something in an enumerated type.
No, let's talk about this. Is it still portable if we went that way?
It's portable, but we have, as long as you stick within the list and you use one from the list that is present on the, on the majority of implementations.
Yeah, I think that would be good, because then you could get their driver developers or storage developers that are not Amazon to come in and say, I would like to add it, and this is my expected, I think it'll still work.
But it does force us to then have to have a list of supported authentication mechanisms for each protocol, because S3 will have its list.
Yeah.
GCS will have its list, which might just be a list of one, and Azure Blob will have its list.
That's okay, but that makes it expandable now. Now we can expand in the future, and it's very clear.
And the default should be, if nothing specified, default is access key secret key.
No, you wouldn't have. Well, okay, yeah, I guess much like if you don't specify an access mode with the PVC, I think you get RWO.
Read once, yeah.
Yeah, so yeah, you could have, if it's blank, you're going to get access key secret, because we know that's sort of the one that tends to work everywhere. Okay, but
like
so
Uh-huh.
it's just going to force us then to have to enumerate all these in our spec and our documents and to explain what they mean.
I mean, the enumeration should be straightforward, because you take a particular official SDK for a particular cloud, and whatever it's the exhaustive list that's supported by them is what we enumerate. We don't care about vendors as much as, like, we start with a particular cloud official API, and because everyone else standardizes on the cloud API, so we can, I think, reasonably say, actually, now that I think about it, that won't work. I was going to say that if you just go ahead and enumerate it for the cloud, we should be good enough. But you see, things like Ceph supports what is that called? Kerberos, right, Jeff?
Sure.
So none of the clouds do that. Now there is that.
Right, but it would just be yet another one in the list for S3.
Correct.
That only Ceph would have an implementation of. And so if a workload said it needed it, that workload would be tying itself to Ceph, which might be acceptable. But most workloads probably wouldn't do that.
Yeah, exactly. That's what I was trying to say. That's correct.
Okay. I can live with that. It's just more work for us to have that enumeration and to add enough docs so that people understand what it means.
Yeah, but I think now it's a clear message, and it's a clear reason, right? And the best part is that now the user gets a clear message saying this is the error because of this reason.
Yeah.
If you say I went S3 with Kerberos and it's Minio on the driver, you're just like, well, we don't support Kerberos, so you're not getting a bucket.
Yeah.
Sorry to interrupt. Like, as far as I understand, RGW does not have support for Kerberos. Ceph do have. So just want to, like, RGW is a Ceph object store. So
I see. Okay, so Ceph object storage doesn't support Kerberos.
As far as I remember, it does not support Kerberos.
I mean, the specifics don't matter. The point is that there's a list, and certain drivers can support a subset of the list. And we'd have to decide if a workload could then say, I want any one of these of these authentication mechanisms, if a workload can be flexible and say,
I don't know if we should allow